This is Geometry, Semester 1. It's the 4th unit called Logical Arguments and the second lesson called Explore and Conjecture Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find this site. So before we get into the questions here, this says the instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So to show you this really quickly, so this is the right site, creatormath.weebly.com. Put that into Google. Hopefully you're able to find it. I sure hope so. This is what the home page looks like. Any of your composition book questions are answered hopefully on this home page, right? So just scroll down till you see comp book and follow all the directions under there. Watch all the videos and it'll explain it to you. We're going straight to geometry because that's where all the notes are, the videos, the problem sets, and vocabulary. This right here is a vocabulary geometry practice study PDF. That's an entire list of all the vocabulary we'll use all year long, and if you're using that, you should be getting 100% on all of your vocabulary practices, all right? So this particular lesson is out of semester 1, so make sure you're in the right semester, you guys. And when you copy this table of contents into your comp book on pages, here it is, 2 through 6, right? This should all be copied, every line, into pages 2 through 6. Make sure you're in the right semester for your situation. Some of these videos are done at different times, so don't be confused. Just follow what you need to follow, all right? So this is logical argument. We're going down to that unit. And it's the 4th one, so 4th down is logical argument. There are 1, 2, 3 lessons. This is the second lesson, explore and conjecture. Here are the pages it goes on in your composition book, and that will be different by the time you watch this, so please go look at the original table of contents and not this video for the page numbers. We're going to click notes. Oftentimes we have to click it twice. In this case it loaded the first time. So you'll be able to open these up and look at explore and conjecture notes. These go in your comp book on the correct pages. So we have basically an understanding of processes and vocabulary for explore and conjecture. Explore, to examine, investigate, question, to be open to the idea we could learn something new. Use any, I'm not sure what that says, that are available to explore a shape and discover any relationships. Use any... Okay, I'm going to get back to that. I'm not sure where my writing is so bad there. I can't even read my own writing there. So apologize for that. Conjecture. Let's try to read this one. A proposed idea that is not yet proven and may even be completely opposite to current understanding/thinking. Write a conditional statement or arrow diagram based on observations from the investigation exploration. Prove is, and it's in steps, is step 3, when a conjecture seems to be true because we can find nothing to disprove it. So ironically, there's an opposite aspect here where if we're proving something true, it's because we can't prove it wrong. Convince yourself and others that your conjecture is true with defined parameters. Process. The above 3-step process works for any subject, including math, to open our mind to new possibilities. So let's see. Let's take these notes from your comp book and let's see if we can answer what we got for the problem set for this lesson. All right? Doesn't seem too complicated. They're just sort of warming us up to a lot of these ideas. And in all fairness, you'll use a lot more of this in science and other classes, but we cover it in math too. So the first word they give us is explore. To examine, study, be curious, consider the unobvious. To be open to the idea that to be open to ideas that could totally change our perspective. Okay, so that's what explore is, just being open to ideas. I mean, remember at some point we thought the earth was flat, right? Being open to the idea it was round was such a deviation from current cultural thought that it just exploded everybody's brain. So that's being open to the idea we could learn something new that could change our perspective. Investigate, to study, go deeper into a subject. Is there a way we can prove what the earth is? Right? Is it flat or is it round? I watched that Netflix on the flat earthers, and I thought that was very interesting. You might find that interesting too. So conjecture. Conjecture is to propose an idea that is not yet proven. to propose something that's kind of radical, and then see if we can go prove it through the next step, which is question, framing what is being looked at, providing focus. So framing up the topic at hand into a good question, and so that we can share it with others and communicate the ideas we have. Process. Proceeding step by step. This is a three-part process. See the notes, right? We're not going to go over all of it again here, but see the notes on understanding that in exploring and conjecturing, we are following a definite process, and that helps to keep us on track. Prove. When a conjecture seems to be true. Okay? So that's what we're talking about, prove. And largely in a proof, we're trying to find something to disprove it. And if we can't, oftentimes we keep it as true. We're constantly looking for what can we show that this is not true. So an opposite aspect going on there. Relationship in geometry. Similarities and differences, right? And the irony is how some of the topics in your classes overlap. You know, in English, you're always looking for similarities and differences when you're writing, right? So in math, you're looking for similarities and differences. A little bit different context, but underlying this is this idea of searching. And it doesn't matter what your topic is, by going through these, what are the similarities, what are the differences, we can start to learn something new. Parameters. Parameters is trying to frame boundaries or borders which contain conjectures. We can't just throw out a giant idea there. We need to contain it. And the parameters will help us to be more specific and to stay on task. If-then statement. A statement in the format of if this, then that. So this is a very simple lesson, and we're dealing with high-level ideas. But you know, if we have this situation, then we have that situation, right? An if-then statement, the all-famous if-then statement. All right, so follow the title to this back to make sure you're looking at the right video for the right practice set of problems. It's Geometry Semester 1. It's the 4th unit called Logical Arguments, and it's the 2nd lesson called Explore and Conjecture Practice on CreatorMath.com under the Geometry tab.